Hey there, Math Hoppers! In this video, we are going to learn the division properties of exponents. So let's begin. Consider this expression, x to the fifth divided by x squared. And as always, I want to see what this looks like in expanded form so we can really understand the property being used here. So if we had x to the fifth written out, it would be 5 factors of x multiplied together. X squared would be 2 factors of x multiplied together. Rewriting the original fraction in expanded form, we would have 5 factors of x in the numerator and 2 factors of x in the denominator. We can then divide out the 2 factors of x in the denominator with 2 of the factors of x in the numerator. So x divided by x is 1 and x divided by x is 1. This leaves us with 3 factors of x in the numerator and 1 in the denominator. X cubed divided by 1 is simply x cubed. So what this illustrates is if we are dividing two powers with the same base, we simply subtract the powers. If we have x to the m power divided by x to the n power, we take the quotient by raising x to the m minus n power. Remember, you have to subtract the power in the numerator minus the power in the denominator, and again, you have to have the same bases. So this is called the quotient of powers property. And really, it's just quotient of powers. I know it seems scary, but it's because we have a quotient, right? We have a fraction, which is division, and both the numerator and denominator are raised to powers. Let's look at a few and make sure we've got this. If we have 5 to the 7th divided by 5 to the 4th, we subtract the power in the numerator from the power in the denominator. We have 5 to the 7 minus 4th power, or 5 to the 3rd power, or 5 cubed, which is 125. All right, let's look at one more. This one, we have a larger power in the denominator, and it's the first time we've seen that. So let's look at it. We can think of it either way. I'm going to give you two ways to think of it. Let's use the rule for now. N to the 2 minus 5, that still works. You get n to the negative 3rd power. Remember that a negative exponent is simply a reciprocal, so that is equal to 1 divided by n cubed, or 1 over n cubed. Another way to think of this is to visualize what it would be like in expanded form. 2 factors of n over 5 factors of n. You would divide out the factors of n in the numerator, and you would be left with 1 in the numerator and 3 factors of n in the denominator, which is 1 divided by n cubed. All right, let's try raising a quotient to a power. What does it mean to raise a quotient to a power? It means we're raising a fraction to a power. So again, as always, let's see what it looks like in expanded form because it is always so helpful. So 1/2 cubed simply looks like 1/2 times 1/2 times 1/2, giving us 1 cubed over 2 cubed, or 1/8. This simply says that if we had 1/2 cubed, we really have 1 cubed over 2 cubed, which is exactly what the quotient to a power rule says. If you have some fraction x divided by y raised to the m power, both the numerator and the denominator get raised to the power of m. And there is the power of a quotient property. Again, it is called power of a quotient simply because you have a quotient here, a fraction raised to a power. So let's look at an example. We have x squared divided by 3 raised to the 4th power. So the rule simply states that don't forget this exponent needs to be distributed to both the numerator and the denominator, giving us x to the 2 times 4 power in the numerator and 3 to the 4th power in the denominator, which is x to the 8th divided by 81. Now let's look at t to the 9th divided by t to the 5th, all raised to the negative 1 power. We're going to look at this two ways. First, let's distribute that power to both the numerator and the denominator. So that would be t to the 9 times negative 1 divided by t to the 5 times negative 1, giving us t to the negative 9th divided by t to the negative 5th. Remember, negative exponents simply switch positions. If it's in the numerator, it moves to the denominator and becomes positive. If it's in the denominator, it moves to the numerator and becomes positive. So t to the negative 5th comes up, t to the negative 9th goes down. You get t to the 5th divided by t to the 9th, and you simply have 1 over t to the 4th. Because remember, t to the 5th over t to the 9th, we can simply divide out the t's in the numerator with the t's in the denominator, leaving 1 over 4 factors of t. All right, let's think of another way to think about that same problem, is simply to remember that the negative exponent means reciprocal. So when we have t to the 9th divided by t to the 5th, all raised to the -1 power, the first thing I'm going to do is flip that fraction, because that's what a -1 power means. It means the reciprocal. So I'm simply going to flip that and change that to a +1. T to the 9th divided by t to the 5th, all raised to the -1 power, is simply t to the 5th divided by t to the 9th to the 1st power, which is just t to the 5th divided by t to the 9th. And now you can go ahead and rewrite that as 1 over t to the 4th. It doesn't matter how you do it. Both ways are great. I just think it's easier to think of it automatically reciprocal, get rid of the negative. Let's look at some practice problems. Okay, so we have a whole lot going on in this numerator. We have 3 factors. We have 2 times x squared times y cubed in the numerator. We have 5 times x times y squared in the denominator. We have this entire thing cubed, which means this power of 3 will go to the factor of 2, x squared, y cubed, 5, x, and y squared. Let's see what this looks like. So we have, distributing that power of 3 in red, 2 cubed, x to the 2 times 3, y to the 3 times 3, all divided by 5 cubed times x cubed times y to the 2 times 3. Simplifying this all down, we get 8x to the 6th, y to the 9th, divided by 125 x cubed y to the 6th. You may think we're done. We are not. We can never leave x's in both the numerator and the denominator, nor can we leave y's in both the numerator and the denominator. Now that we know how to divide fractions with powers, we have to do that. So the x cubed in the denominator is going to completely divide into the x to the 6th in the numerator, leaving us with x cubed. There'll be 3 factors of x left over. Y to the 6th divides into y to the 9th, leaving us y to the 3rd. Now we can clean this up and write our answer. One more, and then we are done. We have x squared divided by y cubed, all raised to the -2 power. This is where I want you to use the negative exponent to immediately flip the fraction and then raise it to the power of +2. So let's do that. We are going to flip. X squared comes to the denominator, y cubed goes up to the numerator, and when we do that, our exponent is positive, because remember, the negative exponent was a reciprocal. It told us to flip the fraction. Now we're not done. We now have y cubed divided by x squared raised to a +2 power. We have to distribute that as we've been doing. So we are going to get y to the 6th divided by x to the 4th, because power of a power tells us we multiply. So we had y to the 3 times 2 divided by x to the 2 times 2 power. I hope this was helpful. Remember, if you're going through your homework and you still don't understand some of them, you should be a subscriber to our YouTube channel. Submit your problems there and we will do a custom video solution for that. Well, until next time, Math Hoppers, have a good one.